Welcome back. We're going to continue our conversation of negative powers by doing a bit of a review first. We learned last time that if you have, for example, 5 to the power of negative 3, that's equal to 1 over 5 to the power of 3. We're finding what we call a reciprocal here. This is a very important word where we're flipping the number onto itself and putting it into the denominator. And then we're also going to switch the sign of the power. So 5 to the power of negative 3 becomes 1 over 5 to the power of 3. Finally, you can also go the other way. But if you have something like, for example, 1 over x to the power of 2, we know that's equal to x to the power of negative 2. We're finding the reciprocal of that. We can go the other way. And finally, you can also recall from previous grades that if you have a fraction in the denominator, well, that's the same as multiplying the numerator by the reciprocal of the denominator. So 1 over, with a fraction in the denominator of 1 over 5, becomes 1 times 5 over 1, which becomes 5. As you can see here, the word reciprocal is really important in our definition. So that's why I want to make sure that we look at it really quickly before we jump into another form of negative powers. Let's look at a new type of example problem. We have here 1 over 3 to the power of negative 2. Well, I'm actually not going to start out by solving that out. I'm first going to notice that 3 to the power of negative 2 is equal to 1 over 3 to the power of 2. I know 3 to the power of 2 is equal to 9, but I'm not going to solve this part out. Instead, I'm going to keep it as is, and you will see why. Well, if I have a negative power of an exponent in the denominator, I can multiply the numerator by the reciprocal of the denominator. So let's look at what we have here. We have 1 over 3 to the power of negative 2, which we know to be 1 over 3 to the power of 2. So the fraction 1 over 3 to the power of 2 is in the denominator. Well, I'm going to take that, and I'm going to multiply the numerator of 1 by the reciprocal of the denominator, which is 1 times 3 to the power of 2 over 1. Now, this part is where it gets interesting. That whole thing is just equal to 3 to the power of 2. The 1 is, you're multiplying by 1, and you have a denominator of 1. All that stuff can cancel each other out. Doesn't really matter here. We end up with 3 to the power of 2, which is equal to 9. And I kept the exponent here because it's really important that we do so. And I'm going to show you why in the next example. For now, 3 to the power of 2 is equal to 9. To show you why I don't solve out the exponent until the very end, let's look at an example where there's exponents on the top and the bottom of this fraction. We have 6 to the power of 4 over 6 to the power of negative 3. Well, first I notice that 6 to the power of negative 3, that in the denominator, that's equal to 1 over 6 to the power of 3. Well, next I know that whole thing, 6 to the power of 4 over 1 over 6 to the power of 3, that's the same thing as 6 to the power of 4 times the reciprocal of the denominator. Reciprocal comes out again. 6 to the power of 4 times 6 to the power of 3 over 1. Well, that's 6 to the power of 4 times 6 to the power of 3. We know that we can use the product rule here because the base of 6 is the same. So we're simply going to add the exponents together. 4 plus 3 is equal to 7. So 6 to the power of 7 is equal to 279,936. Some of you more eagle-eyed students might have caught something on. Wait, Mr. Kim, there might be an easier way. You're absolutely right. There actually is an easier way. So this is method 1, and let me show you what method 2 would be. Here I noticed from the very beginning, the base is the same on the top and bottom. It's 6. 6 to the power of 4 over 6 to the power of negative 3. So I know that's equal to 6 to the power of 4 minus 3 because I can subtract the exponents because it's quotient rule. So minus becomes a plus. 6 to the power of 4 minus 3 becomes 6 to the power of 4 plus 3, which is 6 to the power of 7, which is 279,936 again. So either way, you can use a quotient rule to get the same exact answer. Use whatever method seems easiest to you. Let's look at one final example. It's kind of similar to what we've been doing. So we have 16 over 2 to the power of negative 3. Well, first I notice that, the bases don't look like they're the same. So maybe I can't use the quotient rule here. That's wrong. You actually can use it because of the fact that 16 is a hidden base of 2. 16 is equal to 2 to the power of 4. So I'm going to rewrite this using the first method. 2 to the power, so that whole thing is equal to 2 to the power of 4 over 2 to the power of negative 3, which is equal to 2 to the power of 4 over 1 over 2 to the power of 3. Well, I'm taking the reciprocal of the denominator, so that's 2 to the power of 4 times 2 to the power of 3 over 1, which is equal to 2 to the power of 4 times 2 to the power of 3, which is 2 to the power of 4 plus 3, which is equal to 2 to the power of 7, which is 128. Now, just to show that I can use the other example too, the other method as well, I'm going to use it here too. This whole thing is equal to 2 to the power of 4 over 2 to the power of negative 3, right? We started with this in the previous example. In the previous method. Well, here I'm going to use the quotient rule because the base of 2 is the same. So that's 2 to the power of 4 minus 3. So I know minus minus is a plus. So that's 2 to the power of 4 plus 3, which is equal to 2 to the power of 7, which is 128. As you can see, it's the same answer again. Both methods are okay. Use whatever fits best for you. Let's wrap up with some vocabulary. When you take the negative power of a number in the denominator, so it's in the bottom of a fraction, 1 over x to the power of n, negative n, it's the same as multiplying by the numerator. The numerator by the reciprocal of the denominator. This thing's really important. It's really important that you're familiar and comfortable with finding the reciprocal and with multiplying the numerator by the reciprocal. If you understand this part, then the rest of this is pretty simple. So make sure that you understand this part moving on. And finally, I want you to use what you know about dividing by fractions. So finding the reciprocal of the denominator, as I just said, use it to solve these questions. For example, if you have 1 over 4 to the power of negative 2, that whole thing is equal to 1 over 4 to the power of 2. There's a lot of fractions inside here. So let's break it down. That's equal to 1 times 4 to the power of 2 over 1. Take the reciprocal of the denominator, 1 over 4 to the power of 2, to make it 4 to the power of 2 over 1. So that whole thing is just equal to 4 to the power of 2, which is equal to 16. When you have two bases, you have a base on the top and the bottom, and the base is the same, well, pretty simple. We can use the quotient rule here. So that's 4 to the power of 2 minus 2. And as long as you're familiar with the fact that negative, a minus is a plus, this part's pretty simple. 4 to the power of 2 minus 2 is equal to 4 to the power of 2 plus 2. That's equal to 4 to the power of 4, and that's equal to 256. Now, we've covered a lot so far. We're just going to do one more about negative powers tomorrow to make sure that we're truly mastering this topic. For now, once again, I'm very proud of you for all the hard work you're putting in. Let's keep going. Make sure to like, comment, subscribe. See you tomorrow.